A number of reasons for why we'd like to build models to predict stock movement. For example, we could apply this to building stock recommender systems, to detecting illegal insider trading, and even to mitigate vests and help people invest safely by telling them which kinds of stocks to buy. We'll be given some market data from Intrinio and news data from Thomson Reuters, and our goal will be to predict assigned confidence value that indicates how confident we are that the stock will increase. Note that the confidence value is not the market return, but we will actually be predicting stock prices using a regression model. Here are the features for our market data. We use a number of technical indicators. Note that the bottom two is just a rolling 7-day average of a particular stock price, and the EWMA is an exponentially weighted moving average for a particular stock. We have evidence that market indicators have been used successfully in regression and classification tasks involving price in the past. On the left, we see a plot of the close, rolling 7-day, and exponentially weighted moving average of a particular stock price. Let's take a look at our news features. The bottom two, the headline coefficient and the TF score, are added features that supplement the news data already given by Kaggle. The headline coefficient is just a probability that the stock will increase given a headline, and the TF score is the mean TF-IDF score for a particular news headline. Feature engineering here. Here we plot the count of news in all of our features over time, and we observe that most news happens toward quarterly events, such as earnings announcements. Here, we plot the top 10,000 words across all headlines in our features. This gives us a sense of how our TF-IDF vectors might compare across different headlines. We do a few things to make our model a little bit more resilient to outliers. The first thing that we'll do is discard price points above the 98th percentile and below the 2nd percentile. The second thing we'll note is that because of the housing crisis in 2008, there was a much larger fluctuation in price points, so we'll consider data only from 2009 onward. So how can we predict price and how can we predict movement? Well, we'll take two approaches. To predict the price, we'll use a regression model, where our evaluation metric will simply be the root mean square error. And to predict movement or confidence, we'll use a classification model, where we map each price to a 1 or 0 depending on whether it increases or stays the same. Tree-based classifiers have a number of advantages and are used successfully in the literature for both regression and classification tasks. Here's how we'll train our model. We'll use 5-fold grid cross-validation in an 80-20 test train split. We'll use early stopping to prevent overfitting, so we'll stop when the number of training epochs reaches a point that does not improve the validation score. And finally, we'll train XGBoost and LightGBM models on both regression and classification tasks. The following are our regression results. We see that LightGBM outperforms XGBoost in terms of root mean square error on the market data. We can see that the LightGBM model finds a better fit for the market data than the XGBoost based on the two distributions. So we've predicted price. Now, in order to predict confidence, we turn it into a classification problem and use a LightGBM classifier. We use an ensemble of LightGBM classifiers to further improve validation accuracy, and we'll use a soft voting method to choose the best score among them. We find the best hyperparameters with 5-fold randomized cross-validation model. We achieve competitive results on our validation set, with a score of 75% using the accuracy metric on the right. On the left, what's being plotted is a probability that our classifier predicted the class label, 1 as a stock going up or 0 not going up. Just to note, on the x-axis we're showing the actual confidence, and on the y-axis we show the price point. So what's next for us? Well, we'd like to perform more extensive cross-validation on our LightGBM classifier. We'd like to compare other models on the classification test to see how they perform. We'd like to incorporate news from other sources and even try to build an MIL, or multi-instance learner. And finally, we'd like to provide better explanations for our model's prediction for scientific value. Thanks for watching.